From powering our homes to connecting us with the world, marine infrastructure has become the backbone of our modern economy. Yet, recent explosions on gas pipelines in the Baltic Sea have led many to wonder how secure these vital systems really are.
There's an emergency at this offshore wind park in the Belgian North Sea. This is just an exercise, but the events are based on a true story.
What we want to test is actually when people land on one of these offshore infrastructures and pose a possible threat to the wind farms. And then the second part is the cooperation, collaboration and countering threats by the different partners of the Belgian authorities.
The scenario is inspired by a real incident when a boat with migrants stranded in the English Channel drifted into a Belgian wind farm over a year and a half ago. In this exercise, control centres on land call the vessels at sea, coordinating the rescue of the alleged migrants who are trapped by a wind turbine. The situation takes a darker turn when armed smugglers seize hostages on one of the offshore platforms. Special police and military units are called in to intervene. The Navy, military, police and even the wind farm operator must work together to resolve the crisis at sea.
We need access to the specialised industrial vessels in the area to go up on the offshore platform. Navy ships are needed for coordination and medical assistance, and helicopters provide fire support and surveillance from the air.
Every year, EU nations stage guard drills known as coast-ex. What sets these exercises apart is the focus on offshore energy infrastructure. This is no coincidence, as wind farms at sea meet 10% of Belgium's electricity needs. And this figure is expected to triple in the next 10 years. Wind farms are just one example of the critical offshore infrastructure that Europe is becoming increasingly dependent on.
The Belgian North Sea and Channel indeed is a crossroad of vital infrastructure, not only on the sea surface but mainly on the sea bottom. And we are speaking about communication cables, but also power cables, pipelines for oil and gas, and these are very vulnerable to different types of threats. And one of these threats is the espionage and sabotage actions by the enemy to our vital infrastructure on the sea bottom. The threat is not only hypothetical, it's a real danger, and we saw that with the Nord Stream incident, which is really a wake-up call for the European countries in order to protect more and more the offshore infrastructure.
The exercise concludes with the arrest of the smugglers, and the safety of the wind farm is restored. But protecting critical infrastructure at sea remains a pressing topic throughout Europe. Minor accidents like boats damaging data cables don't cause much trouble, but a major failure or deliberate attack could have severe consequences, especially for islands and other regions with poor connectivity. In Geneva, we spoke with Professor Christian Burger. He co-authored a study that analysed Europe's subsea cable vulnerabilities just months before the Nord Stream incident brought this issue to everyone's attention.
Do you see a change of perception or maybe awareness of the threats here in Europe?
Absolutely, the cables are no longer invisible. We are now highly aware that an attack like this can happen and that there's a likelihood that it will happen again in the future. And because of that, both the European Union as well as NATO has actually developed quite some plans in order to step up the game. Much of what is currently happening concerns improving surveillance, us understanding better what happens on the sea, but also under the sea. And we also need a very close cooperation between the industry and security policymakers, and the military. Now, getting all of these actors together, agree on best practices, agree on who should do what, is not an easy task.
The important job of protecting and maintaining specific submarine cables is not exactly straightforward. It involves costly and risky procedures that typically require specialised vessels and professional scuba divers. One possible solution to safely address these challenges would be the use of robotics. The Institute for Systems and Computer Engineering, Technology and Science in Porto has developed machines that can monitor underwater infrastructure for long periods.
If you want to do this with a diver, you will need many different divers because they cannot stay so long in the water, and it's also dangerous. So with robots, we are not risking any humans.
As part of the EU-funded Green Deal project called EU Scores, this technology is now undergoing tests at an experimental site in the Atlantic Ocean. 2 robots have been designed to operate in tandem, monitoring offshore energy parks, cables, pipelines and other underwater infrastructure.
This robot could be in a certain place, listening to the environment around it, seeing if there is any intrusion, and it can change its position. So if you are considering from the point of view of defense or security, it's also interesting that the attacker doesn't know where the defender is. And the second one, EVA, is a versatile robot that is used either to map, to inspect, to help in the operations and maintenance of infrastructures at sea, not only cables, but offshore wind turbines or wave energy converters.
Equipped with sensitive cameras, sonars, magnetometers and AI algorithms to identify threats, these machines could ensure a broad and flexible underwater surveillance system.
In the future, it's going to be like cell phones are for us today. So like you have the wind turbines in the sea, and you have a multitude of robots moving around doing their task. Large-scale sonar.
Our infrastructure extends above and below the sea surface, making its protection both a challenge and a necessity in the years to come.